Okay, hi everyone, I'm Alina, super happy to be here. If you don't mind, I will just maintain the tradition that we have here and we'll do a super quick selfie. So please all look happy and say GraalVM. Okay, close enough, thank you. So yes, I'm Alina, I work on GraalVM at Oracle Labs, and Oracle Labs is this very cool R&D unit at Oracle where we're doing a lot of new projects, and GraalVM was actually a research project developed at Oracle Labs. Something like 10 years ago we started working on it, and now it's in a great stage where you can use it in production. And it's also my first time speaking here at Spring.io, and I love it so far, it's amazing, so very happy to be here. So let's talk about GraalVM, GraalVM native image, and Spring Boot. So first things first, GraalVM is a huge project. There are so many things you can do with it. You maybe heard that it's a JDK, you maybe heard that it's a polyglot VM, and we talked about native image today a lot. So it's a bit confusing because there is so much you can do with it. So I just want to mention those basic things quickly. So indeed, GraalVM is a normal JDK. Underneath, as a platform, it's using your normal open JDK with the hotspot VM. So one thing you can do with GraalVM is you can run your Java applications as they are just by using Java command, and they will run on GraalVM as a JDK. And all your tools, libraries, etc. are available to you immediately. And the only thing that is different is that we are replacing the top-tier optimizing compiler with our own brand new Graal compiler that can also give you more performance in the JIT mode as well. But a more exciting thing that I want to talk about today is this native image ahead of time compilation that takes your app, compiles it ahead of time into a native executable that no longer needs a JVM to run. So it's fully functional, fully working on its own. There is no more code loading, compilation happening at runtime, and that is the way how it makes your application start much faster. And in fact, this is the version of the slide that I'm typically showing, but last time I was talking about this, somebody posted a photo, and then my friends from the Clojure community saw it and got a bit sad with me because, as you can tell, Clojure is missing from the slide. So I don't want to disappoint them anymore, and I have a newer version of the slide. So if you are considering tweeting about what GraalVM can do for you, please tweet this version and make my friends happy. Thank you. So let's talk about native image, and we briefly mentioned this in the morning, but we didn't have much time during the keynote, so I want to talk about it a bit more now. So native image makes your application start fast, and that is coming from the fact that there is no code loading, interpretation, compiling, etc. at runtime. And in a way, it can be seen as a limitation because maybe you do want to load new code when you're running your application. But I would say it's just a different way to run and deploy your applications, and it gives you significant benefits because you don't need to do all those overhead code execution operations at runtime anymore. You are moving all of that to build step. And that's the main thing probably that you need to know about native image, is that it's trying to remove all that overhead work of executing code to the build step, so you could do it once when you have time and resources, and you don't need to repeat all those operations when you start your application. So if you ever compiled a larger application with native image and you maybe were thinking why this is taking some time, the thing is that you would still need to spend that time and that resources when you are running your application on a JVM, and the trade-off that native image is offering you is doing this once at build step when you have the time and resources, so you don't need to do it when you actually run your application, and you can get straight to the point of doing the meaningful work that your application is supposed to be doing. So that is startup, but again, as I said, I think startup is great, but I would argue that maybe what is even more important is resources usage. And especially if you're deploying your applications to the cloud, you know that memory is not free and isn't cheap either. So if you can deploy the same application that is doing the same job by using just a fraction of that memory, that will help you significantly make your deployment more efficient and save all those resources and memory specifically. And another interesting thing is minimizing vulnerability. We'll get to that later on in the presentation, but there are some interesting ways about the native image deployment model that make your application more secure by eliminating certain attack vectors. And last but not least, it also offers you more compact packaging. So you can build very small, lightweight applications, and this way you can deploy and scale them faster and more easily. Let's talk about each of those things in a bit more detail to understand how they are happening and what you need to know about native image build process to make it work for your application. So the way native image compiles your application, and I think it's quite fascinating and untrivial, taking something so dynamic and sophisticated as a Java app and compile it into native, is the following. So when you run native image command, and as an input it takes your application in a byte form, it will look at your application starting from its main entry point, and it will try to find all the reachable code. So this applies to your application code, but also to the dependencies, libraries, JDK, classes, etc. So it will try to find all the code that is reachable from the main entry point, so everything that is actually meaningful and necessary for your application to perform whatever it is supposed to perform, so that it will include only that code in that produced native executable and will eliminate everything else. And that is the way how native image makes your application more lightweight in this final compiled native form, because it eliminates everything that should not be there, because we don't need that code execution infrastructure anymore. And this ahead-of-time compilation, it's a big part of the native image story, but there is also another one, and that is snapshotting. So another thing that we are doing at build time, we will snapshot the application, so it can start with pre-populated heap, so we don't need to fill that heap at runtime. And with those two things, that is how native image prepares your application for runtime. And just to compare running on GraalVM native image, that's IoT here on the slide, versus running on the JVM. JVM in this case can be OpenJDK, GraalVM, JVM, doesn't matter. So if we compare those two execution modes, those are the operations that need to happen before you can run your application in this warmed up peak performance stage. So when you're running on a JVM, you need to load jar files, classes themselves. You need to look at them, start interpreting, start collecting profile information, compiling. And what's interesting, I mean, we all know and love JVM for the best peak throughput, but the thing is that this compilation process is sophisticated, and there are multiple ways how JVM evaluates what needs to be compiled and when. But sometimes it could be the case that some methods never even make it to the compilation stage, so they stay in interpreted. And usually those are the methods that are not executed often, but still it adds up and it can have impact on the performance if some of the methods are still executed in interpreter. But then, you run the application for a while, it warms up, and then it reaches its peak performance, and it's all great. But as you can see, it takes some time, and that is that cold startup times that we sometimes observe when running your application on a JVM. Now, on GraalVM native image, since we did all of that already when we were building the app, everything we need to do is just load the app and start executing immediately with peak performance, because we already analyzed and compiled it in advance at the image build step. And that is what's relevant for startup performance and time it takes you for your application to start on a JVM versus native image, but similar thing applies to resources usage. So when you're running on a JVM, you need to keep memory around for all the things that are needed for your application to perform, and that applies to your actual application workload, but also all the code execution infrastructure that is there in place to dynamically execute your code at runtime. So you need to keep memory around for all those things that are both your application payload, but also the code execution infrastructure. While on native image, you do have some minimal runtime components coming from native image and embedded in your native executable, but they are very slim, very lightweight, and you can see even visually how significantly less memory you need when running on native image. And then this gets even more interesting when you want to scale your application, so you want to add more instances of it, and you can see how that, I would say, escalates quickly on the JVM versus on native image, because native image uses way less memory, so as you are scaling, you only need to scale the memory for that actual application payload. But that's enough for the slides, I would say. Let's see some demos. So the first demo I want to show you, and let me close this. We've seen Pet Clinic this morning, but it's a standard for Spring benchmarking, so I want to show you Spring Pet Clinic as well. And for that, we will also look at some different things comparing to what we looked at this morning. Okay, praying to conference internet to not fail me. All looks good, and I just want to point out that this is running on my machine, which is a decent machine, but also not the most powerful one. So probably this is not a perfect benchmarking setup because I'm also presenting from this laptop and I have my Docker environment running, but this is good enough to compare between two execution modes. So our app is on in the GraalVM mode. It took, again, on my machine, 1.5 seconds to start. And if we go to our app, we see our Sprint app. Okay, I think this is scaled, so let me zoom out. So everything we saw before many times. But let me run it in native now, and let me clear to move this back up. So what I have here is I have my app that is already compiled in my target directory, and this is this Sprint Pet Clinic native executable over here. So you can see it's fairly small for such a bigger web app that is also talking to the database and is doing quite a bit of work, but also this is a very basic configuration without any compression, any additional size reducing techniques. So if I wanted to, I could have reduced this size as well. But this is good enough for me and for the sake of the demo. So let me run it. Okay, this is on, and it started in 0.3 seconds now, so I would say this is significantly about, 5x faster at least. And if I go here, it's also working, so this is now working in the native image mode. I can do various things. I can maybe, I don't know, find an owner, and I can add a new pet. So let's try adding my cat. So the closest thing to her name in English would be, I guess, Flufflake. And this is mandatory, and it's a cat, not a bird. So let's add it. And it's being added, and it's also being put in my database. So this is all working in the native image mode just fine. And you can see how much faster that app was in native image mode. But let's kill it, and let's do some more exciting stuff. And for that, I have another app. And let me transition to the VS Code here so I can show you what it's actually doing. So here I have my Sprint app, and I have this very sophisticated code here that is exposing my hello endpoint. So let's run it, and let's run it in the JIT mode first. And let me just maybe move this up, and let me check my Java version. Okay, so here I'm on GraalVM 22.3, which is the latest feature release of GraalVM. So let's go ahead and let's run our app. So Spring Boot run. And I think I would need to map the port because VS Code didn't do it for me. So let me quickly do it. So I can go to the browser and see what's happening there. So localhost, and I just need to navigate to the right endpoint. Oh, typo. Hello. So here's my app. It's not doing anything sophisticated, but we will stress it a bit more now and see how it performs under load. So that was the GraalVM mode. And again, I have it already compiled. So it's here in target directory, and this is my demo natively compiled application. You can see it's also smaller, right? So let's run this one. It's in target, and it's called demo. So you can see how it started super fast, and as we go there, it's still doing what it's supposed to be doing. But as I said in the morning, startup is great, but maybe this is not something that I care about most, right? So maybe I have a long-running application that doesn't start that often, and for me, maybe startup is less of the consideration. So let's see if our app is improved in any other meaningful way. For that, I will do the following. I will send several requests to my app so we can observe its performance a bit over time. And I will also use a tool called PS Record to look at my process and output information about how much CPU and how much memory that my application use. And for that, I will also switch between the modes. Where is it? Set command. So I will just pass several commands to quickly switch between the JVM and the native image mode, just so we can compare different benchmarks running on the JVM and running in native mode. So for the first thing, where we want to observe the application behavior, let's do this. Let's do record, and let's do JVM. And this will send several requests to my app over time, and will give us those CPU and memory usage numbers. Should be done now in a few seconds, and now it's done. And the result of running this benchmark is here the following. It produced this chart for me. So what is shown on this chart is the blue horizontal line, that is memory usage, and then the red vertical ones, that is CPU usage. And what's happening here is quite interesting. So you can see below that the horizontal line is showing us the timeline. So I would say up until 2 seconds, my CPU is quite busy. So it's doing a lot of work. And that is all that startup work that we were mentioning in the beginning, right? I'm starting my application, so I need to load JVM, load my classes, interpret, compile, collect profile information, etc. So that is what's happening in the beginning, and then we see a few more CPU spikes over time when those requests arrive and need to be served, but we see how much, significant pressure our system is dealing with when we are running our application on a JVM. So let's see if this is any different in the native mode. So let's do the same, only this time we will look at our native application. So clear, record, and let's look at the native app. I don't know about you, but every time I see this longer output, I'm getting a heart attack for a second, because to me it looks maybe that's some, warnings or error messages, and I get super scared. But it seems like it's fine. And so just to recap, this is my app when it was running on the JVM, and this is the same app on the knob in the native image mode, right? As you can see, the picture of the resources usage from our system is quite different here. So memory usage overall, over time, on average, is much lower. But also you can see that the CPU is not used as often. So it's doing some work once in a while, again, when those requests arrive and need to be served, but it's doing way less work at runtime. And this is a very nice deployment model specifically for web services, and maybe those that are under not so high or not so constant load, because when they are idle, it's very easy for your system not to use any of those resources, and then when they arrive and need to be served, it's very easy for your application to get up and start serving those requests. But in the meantime, when your application is idle, it is not consuming any additional resources. So this is really nice, but that was still around startup and resources usage, and we all know and love JVM for peak throughput. So how does native image compare to running on the JVM in terms of peak throughput? Because the way native image compiles and runs the application is that the compilation is happening ahead of time. And the way JVM is so good in optimizing your code for a peak throughput is because at runtime, it observes the application behavior, and it collects profile information about it on the go, and then it adapts to your application behavior on the go by seeing which parts of your application are executed more often and adapting on the go. So that's pretty amazing, and that's pretty hard to beat, especially if you're compiling ahead of time under a closed world assumption. So let's look at our app, and let's give it some significant load to see how it will perform under that significant load. And for that, what we will do here is we will send, where is it? Here. We will use the tool called Hey, and we will send 1 million requests to our app, and we will look at the performance numbers of how our application behaves in those two execution modes. So let's do this. And let's run again on the JVM first. So this will take a couple of seconds because that's more meaningful load. And after that, as it will send all those requests that will be processed, it will output performance numbers for me. So let's give it some more time, and we are done. So this is the output coming from Hey. It's very nice and quite visual, I would say. We see that all our response codes are good. We can look at latency numbers, but for me personally, what I'm always curious about is peak throughput numbers. So let's look at that, and here we have 80K requests per second. I mean, it looks pretty good for me, but also we wouldn't know unless we compare with native. So let's see how native compares to that peak throughput numbers. For that, let me just remove this, and let me run this in the native image mode. So again, the same benchmark, we are executing our demo natively compiled app, and we are sending 1 million requests to it. So who thinks this will be faster than JVM? Okay, there are some optimistic people in the room, and quite a few. I'm happy to see that. Okay, who thinks that this will be slower? Okay, I would say it's 50-50. Let's see. So it was 80K for the JVM, right? Let's look at native image. It's 67K, which I personally would call on par, because I know how hard it is to ahead of time compile code and make it perform, comparably with JVM. But maybe this is not the result you'll be happy with, and maybe in addition to fast startup, low memory usage, etc., you also want that absolute best peak performance for your native app. So is there something you can do about it? And the answer is yes. And I have yet another version of this app. It's again here in Target, and it's called Demo Optimized. So this is, again, a native version of my application that I have built in a different way. So what I did there was 2 steps. I built an instrumented version of that app, and then I ran that app in the instrumented mode, and I sent relevant load to it to go and collect profile information about it. I don't know if I can find it quickly here. So somewhere here, there should be this default, okay, that's the one. So that's the profiling information about my application. So I ran my app, it was actually running, it was receiving load, it was doing what it was supposed to be doing, and then native image was observing the application behavior and collecting this profile information for me. And that was so that we can go ahead and use what it's called profile guided optimizations, and once again build my native image only with those profiles in mind, so that native image would optimize it for the best peak performance at runtime. So in a way, this is taking a sneak peek into what your application is doing at runtime, so that native image can observe it, and in a way like a JVM does, observe what the application is doing, which parts of the application are warm, and apply optimizations and optimize for the best peak throughput, having that runtime information available at build time, which is pretty cool. But again, let's compare and let's run this optimized version of our application. Where was it? Here. And I think the one that I need to pass is optimized. Okay, it picked up the right version. Okay, who thinks that this will be faster than the previous native app? Okay, I'm happy that I convinced you, but who thinks this might be faster than the JVM version? Again, very optimistic people. I love it. Okay, is it done yet? I think it is. Let's look there. So if you recall, the JVM number was 80K, then plain native image was 67K, and here what we got is 81K requests per second, which is definitely on par and even slightly better than running on the JVM. So of course, this is just one app, and here I need to say this big disclaimer that always test on your application, because every application is different, it's doing different things, pulling different dependencies, so there is no generic answer to how fast native image can make your app at runtime. But what I wanted to show here is that if you're using this optimization, you can achieve peak performance that is on par with the JVM, also with native image, in addition to all those other benefits, so fast startup, low memory usage, etc. So it's possible to achieve good peak throughput if that's your goal, but it could be the case that maybe you are more interested in that other part of the story, which is lower resources consumption. So maybe, I don't know, maybe you're working on the app that is not a production app, but maybe your hobby app, your pet project, and you want to run it in an environment while using very little resources. So maybe some constrained environment, or you could be having other reasons and you want to optimize for using as little resources as possible. So for that, I will go ahead and I will abuse my app a little by constraining its the memory that is available to it by, I would say, 4x here. So let's see if our app can consume less memory and still do some meaningful work. So I will run this optimized binary and give it less memory, and we will see what kind of performance impact that has. So that will be, I think, native constraint. Okay, this should be good. Starting, optimized. Okay, this should be fine. Let us see. Okay, who think this will crash? Okay, super optimistic people. Who think this will be somewhat fast? Nice. I share your attitude, but let's see. So I think the last performance number that we got with the optimized native executable was 81K. Let's see how this performs. So this time we got 73.9, almost 74K. So this is slightly lower, but this is a bit of a trade-off, right? So you could optimize for the best peak throughput, then please give some, reasonable amount of memory to your app. But then if you want, and that is how you achieve the best peak throughput. But then if maybe you're running in a resources constrained environment and you want to optimize for reducing resources used and you don't care that much about getting 100% of peak performance, you could put native image in this constrained environment and it will still do a good job, will not crash, will show decent performance. And that is something you can accomplish if you want to reduce resources usage. That is that. Let's talk about other things. So the security part of native image, and that's the topic that I like a lot, and I wish we talked about it more often. So one thing to know about native image is that we said the compilation is happening at build step, so no new unknown code can be loaded at runtime. And again, this can be seen as a limitation. So maybe you do want to load that new, random code. But in a way, it's also making your app more secure because it's giving you control over what happens at runtime. And there are no surprises, no new code execution when you actually run your app. What is interesting is that also the code that is reachable, so only the code that is involved in your application behavior and doing what it's supposed to be doing will be included in your app. So maybe you are pulling a lot of dependencies and maybe you're not so sure about some of them. And what's great about native image is that it will eliminate everything that you are not using and only put the parts of your code that are actually functional in that produced native executable. Now, things like reflection and serialization require an explicit allow list from your side because those features are dynamic. So if you're compiling your application ahead of time, you need to tell native image that those are dynamic things that I want to use at runtime so that native image can build an app being aware of those dynamic features even when compiling ahead of time. And that's what also interesting, there is no just-in-time code execution at runtime. So all code is executed and compiled ahead of time. And there are some attack vectors and ways of attacking application that are targeting specifically just-in-time compilation. So those are not possible in native image because there is no just-in-time compilation anymore. It's all happening ahead of time. And talking about compact packaging, so I think Sebastian mentioned this in the morning, but just to add a few more things to it, so the way you can reduce your application size with native image is quite significant. What we are looking here is your application size when running on a JVM versus running on native image, and we are gradually going down, trying to reduce this image size as much as possible. So the red bars that is running on the JVM and the green ones that's running on native image. And then if for some reason you care about application size really much, one more thing you can do is you can build a fully static native image that will be fully functional on its own, no external dependencies whatsoever. But you can take it one step further. Since it's a native application, you can use the tool called UPX and compress it even further and get to a very small image size. One thing to keep in mind, though, is if you're compressing your image, again, as many things in our life and in software engineering, everything is a bit of a trade-off. So if you want to compress to a bare minimum, this can have a runtime impact. So again, you would need to choose, do I want to have good runtime performance, or do I need to do the minimal packaging size, but at the cost that it maybe will take some time to like decompress my application at runtime. Okay, what's the catch? Because maybe it sounds too good so far, like a sales pitch. Maybe I want to hear about the bad things. And sometimes that's the question I actually get. So what are the downsides of GraalVM, or what are the things that I need to be aware of? So one interesting thing is GraalVM and reflection. Who here have heard that GraalVM doesn't support reflection? Okay, a lot of people, still a way to go for us. So that is not true. GraalVM does support reflection, but there are things you need to know. And one thing that, again, I said this a few times today, but native image compiles the application ahead of time under closed world assumption. So those dynamic Java features pose a certain challenge, because before your application runs, there is no way of knowing what will be happening at runtime, at least by default out of the box. So to make those dynamic features and reflection specifically work in native image, there are some things to know. One is that native image will try and figure out some of more common, more usual reflection calls on its own. So even without any configuration, native image will look at your reflection API calls, and it will try to resolve some reflection methods and calls out of the box automatically. But sometimes for things that are a bit more sophisticated or unpredictable, that wouldn't happen. And again, there are a few ways to handle that as well. One thing is that native image includes tracing agent that can observe your application behavior and will output those observations in the form of JSON. And those JSON files can be picked up by native image at the build time to have information and awareness and configuration of those more dynamic features and build your application with those things in mind. So you can write the tracing agent, it will observe your application behavior on the JVM, and it will output configuration that native image can pick up. So that is really nice and very helpful, and I was talking to the Sprint team yesterday, and they said that they are using the tracing agent as well, and it's quite helpful. But also, I would not say that it's a silver bullet, so it's helpful and it eliminates a lot of manual work, but I always recommend that you go and check those configuration files and see if they are complete. Just, have critical thinking and look at the files to make sure they are complete. So that is tracing agent, but also preferably that configuration will be coming not from the tracing agent and not from you, but from the libraries or frameworks that you are using. So in the best case scenario, the library that you want to use in the native image mode will come with this configuration already in mind. And for that, I want to show one good example of the cool kids that already do it. So let me quickly Google this. So you all know H2, right? And if I go to the actual source code here, and I will look for something called reflect config. This is the reflection configuration file that, for example, H2 is shipping with the library itself. And this is something that helps native image figure out how to build your application if it's using H2. And that's the configuration that is needed for native image. And it's very nice when your library or framework is shipping this with them kind of built in. But it's very interesting also what they are doing here. So configuration here is conditional. And only if this type is reachable, this method is registered to be reflectively accessed by native image. So this is very nice because those conditions help reduce image size and help improve this configuration. So the way they're doing this here, it's very nice. And another way where this configuration can be coming from is this reachability repository that we mentioned this morning. So if we go here, this is a centralized place where, as we said, community members and library and framework authors can contribute and share and reuse configuration, because it could be the case that somebody is already working with the same library as you are, and they figured this out, all the reflection and configuration that is needed. So it would be nice if you could go ahead and reuse that config from this centralized place. So here, as you can see, we have a lot of stuff that is already available for you to use. And the very nice part about this reachability repo is that Spring Boot, for example, comes with built-in support for this repo. So if you are building your application and it uses one of those dependencies and you're using Spring Boot at the build time will go and automatically put this configuration, so you don't need to be even aware of this or configure any of this manually. But also, the way you can consume this configuration from here is through our Maven or Gradle plugins. So there are plugins that are developed by our team, so the GraalVM team, that will help you build and test your application. And actually, let me showcase it on the example of the app that I was showing you previously today. So this is my native Maven plugin that is coming from GraalVM build tools. And if you ever want to build your first application, I do recommend that you use those plugins because they will help you a lot. And also, if that app that you're trying to build is a Spring Boot app, this is also being used by default, so you don't even need to specify it manually. But why those plugins are so cool is because they will help you test your application. One more thing I can have here, I can specifically add access to that repo and say, hey, I know that this repo exists. Go ahead and figure out configuration for my libraries automatically, and then other build tools will do it for you, so you don't need to write any manual configuration at all. And another thing that is cool about this is that this is the place where I can pass various arguments to my application build. So let's say I want to enable monitoring features, and for that I need to pass this command line argument to my native image build. But if I want to invoke my build from Maven, this will be the place where I can do it. Or also, if I want to use virtual threads from Project Loom, that is also already available and supported in GraalVM, only I would need to pass the enable preview flag in a similar way like I do on the JVM, because it's also a preview feature in native image. So this is very helpful if you want to use third-party libraries and you need to understand and make sure the configuration will be working for them. I do recommend that you check out the reachability repo, but also if you're using our Maven Gradle plugins, or if you're building a Spring Boot app, this just happens automatically, which is pretty cool. Okay, and let's move on. So we were talking a bit about downsides, or other things to be aware of GraalVM, and things you need to know before you build your app. And another thing that is here is that require build time step. So this is rather new, I would say, for Java application. All that compilation that we are making to produce our native executable, it requires some time and some resources, so be prepared for that. But again, that's the overhead that you would have to pay anyway when you start your application. And another thing that you need to know is that native image needs to build your application on the same architecture and operating system that you are planning to deploy. I mean, by default, but also you can use CI/CD systems. But in general, if I'm compiling my application on my ARM Mac, it will produce a native executable that is compatible with my ARM Mac. But there are things to, again, work around here as well. So one thing you can use GitHub Actions, and we actually have our own action that you can use on GitHub Actions. And what is pretty cool, we are constantly working on reducing the resources and time that it takes for your application to be built with native image. So even larger applications, I would say, also including Spring Boot applications, and I'm pretty sure we even tested Pet Clinic there. So even those can be built with 2 GB of memory. So even in those environments when you have maybe less resources available to you, but you want to do this kind of cross-platform compilation, it will be possible as well. And what we recommend in general about the way how you approach building native applications is that you develop on the JVM because you get kind of faster feedback loop. But then for native image, you compile to native, not on every single step maybe, especially if you're making changes that are more around your business logic, but then you're compiling to native once in a while or as a more or less last step in your CI/CD pipeline, but you don't need to constantly repeat that step as you're developing your application. It will be just easier for you if you develop on a JVM and then compile to native when you're more or less ready to test and take your application to production. And yes, if you want to achieve the best peak throughput, I would say it's on par with the JVM, but if you need the best possible peak throughput, you would need to use something like profile guide optimizations like we've seen before. Okay, and I'm running out of time, so I will try to speed up here, so bear with me. So I want to talk a bit about native support in Spring Boot, but there will be also a very nice session about this tomorrow, so I will not stop here much. But a few important things that I want to mention are the following. So first, support for GraalVM and native image compilation was happening in a separate Spring experimental project, which was called Spring Native. Does anyone here remember this separate Spring Native project? Okay, quite a few people, I'm with you. It was very cool to try and build the first Spring Boot apps with native image as well. And then in March 2021, they announced the Spring Native Beta, and I think that's the time when GraalVM and native image actually became available at start.spring.io. So that was the point when it got even easier to build GraalVM and Spring Boot applications. And then in November 2022, so last year, they announced GA, so now it's absolutely possible and supported to build such native applications. And what I wanted to say here is that it may still look new to you, all this native image support in Spring Boot, but there was a lot of work to make this happen, and the project and this native image support is quite mature. So if you want to give it a try, I don't see any reason why not. And one more thing to be aware of when you want to build your application with Spring Boot and native image is now that there is this new IoT processing step in the life cycle of your Spring Boot application. And that step is needed to prepare your application for native image compilation and make it a bit more friendly towards native image compilation. And what happens here is that Spring, as a framework, will look at your app and it will optimize and transform your code that is in a way that is more IoT friendly, but also in a way that it's a bit more efficient and runtime, for example, by eliminating some of that reflective calls. And it will also produce some things, again, to aid the native image build. That could be in the form of the actual Java source code, so it will produce actual Java source code, but also it will produce those configuration files for native image, such as, for example, the reflect config file that we saw in the H2 library. So it will produce those files, so it's easier for native image to build your app having all that configuration in mind. And getting into some more deep stuff here, I hope you maybe don't need to do it. So I hope that most of the apps that you will build with GraalVM and Spring Boot will just work out of the box. And that is the happy path that we expect from most of the users to stay on and don't need to do something like here. But maybe you're doing something custom and then you already know and are aware that maybe this is the place where my application is doing reflection, and is there an easy way from within the app to make native image aware that I want to make reflection call over here? And for that, Spring offers some nice ways to do it. So the one above here is the way you would register a class for reflection. So if you know that there is some reflection happening on that class, that's the way you would pass that information from within your application to the native image build. And the second way here is similar in a way. Here we are looking at resources, but in a similar way, you can configure all things for native image. So reflection, resources, serialization, etc. And those are the two things that will help you make your application work with native image in case something maybe didn't work out of the box as expected. But hopefully, this is not something you would need to see. OK, and those are the native build tools that I mentioned before. So those are our official Maven Gradle plugins. They are included in your Spring Boot application if you are adding GraalVM native image dependency. But just to be aware of, they are also standalone plugins that you can use in your application to build native image applications easier and faster. And they also offer some testing support for JUnit. And actually, speaking about JUnit, so some time ago, I think a few months ago, they made this announcement that they are adding 2 new additional annotations, specifically for native image, so that you want to specify, if you want, you can specify that you can test your applications in native image mode, so either enable or disable it for testing in the native image mode. OK, and what's new in GraalVM? So if you want to use the latest GraalVM builds, at the moment, those would have to be developer builds. So we build those once in a while to test how things work. And if you want JDK 20 builds, those are available as developer builds. And then if you want to wait for normal, tested, production-ready builds, those will arrive on June 13th. Very excited about that. And we are working to add new monitoring features in native image. So there are features that work from native image, like within the native image itself. So for example, in the last release, we added support for JVM stat, so that you can observe your application, for example, in Visual VM in the native image mode as well. And also, as I heard from the Micrometer people, they have also very nice native image support out of the box. I haven't tried it yet myself. I still want to try it. But also, if you maybe tried it, come and talk to me. I'm very interested how is that supposed to be working. But as I heard, it works amazing out of the box. So super excited about that as well. And if you want to know what else we are working on, GraalVM is also an open source project, and we have this community roadmap on GitHub. So there you can see the things that we are working on, what is coming up soon, what is coming up maybe later, and you can share your feedback with us if you want to give us your feedback on which features you think will be more important or more useful to have in upcoming releases. And one of the things that is coming up in the future, and I want to mention specifically, is that we are working on constantly adding and improving our GC implementations that are available in GraalVM. And this is on JVM, so not in native image yet, but we will have ZGC coming on GraalVM JVM. So if you're using GraalVM as a JDK, this is something that will be available for you very soon. And in terms of what is next for native image specifically, so we are working really hard with many framework and library authors to make sure that you can use all those libraries in your native image mode as well. We are working on improving performance of native image at runtime, but also improving performance of the native image build process. So it's using less resources and it's faster, and it's showing you some valuable output as you are building your application. And we are working also to reduce the build times so you can get faster feedback loop. And also one of the things that we added recently is a quick build mode where you can specify this -ob command, and this way the compilation phase will be faster so that you can get kind of faster feedback loop as you are developing your application. Okay, so to get started with GraalVM, you can get the builds from our website, or if you're using SDK Man, they're available there as well. And there are a lot of very cool GraalVM sessions actually tomorrow. So that will be this from Spring Native to Spring Boot 3 that I'm very excited about, and I'm planning to attend that as well. That will be testing Spring and GraalVM applications from Sam. And that will be even a polyglot talk, which again, I'm super excited about because that doesn't happen that often at conferences. So that will be making Spring applications polyglot by using Python from your Spring app. And with that, that's it. That's my name, that's my Twitter handle, and I think you can also message me on that conference app. If you have any questions, I think we have 1 minute left, but also please come to me, come talk to me and I'll answer your questions. And I have some GraalVM stickers. And with that, that's all. Thank you so much, and please write the session in your app. Thank you.